Factoring polynomials. When factoring, we can use the remainder theorem and factor theorem to help us find the first factor. This can be then used as the divisor to find the other factors. So to find the factor, you can use this formula. Factors of the constant term, so remember the constant term would be the term with no variable, divided by factors of the leading coefficient. So that is the number in front of the largest exponent so we want to put in descending order, and that would be why it's in front. So if we look at that situation in this polynomial, the possible factors would be factors of 6 divided by factors of 1. So the factors of 6 are 1, 2, 3, and 6, and the factors of 1 are 1. Now, at first glance, you might think that is all of them, but you have to remember that we have to include negative numbers. Two negative numbers multiplied together could be a possible factor as well. So for example, -1 and -6 could be true. So we're gonna actually have to put plus or minus signs in front of all of these. So those are all the possible factors of this polynomial. Now it gets time consuming because 1 divided by 1 is 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. There's a lot of options. So 1 is always going to be a factor. So because of that, we sometimes use what's called the integral zero theorem. So often we'll just use the factors of the constant term to find the first factor. The relationship between the factors of a polynomial and the constant term of the polynomial is stated in the integral zero theorem. So if we look at example 4, what are the possible integral zeros of this polynomial? All we're really going to look at are the factors of -8. So if I was to list the factors of -8, it'd be 1, 2, 4, and 8, keeping in mind that you could have two negative numbers, so we have to list all of the positive and negative factors for -8, because you could have a positive times a negative or a negative times a positive to make -8.